Today we're going to talk about adding and subtracting rational expressions with unlike denominators. I'm going to start very quickly by talking about how to add and subtract fractions with numbers. So let's take an example like 1/5 plus 1/4. In this, I'll use a method I call the smiley face method. The reason I call it the smiley face method is because I can simply draw a smiley face on top of my picture. And you can say, whenever you add two fractions with different denominators, smile. So I do the smiley face method and I multiply the 4 and the 1 together to get 4. So 4 plus the 5 and the 1 together to get 5, and my new denominator is 20. Now, all I have to do is add the numerator, and I'll get 9 divided by 20. Here, this cannot be reduced any further, so this is my answer. One of the things you want to be very careful of is when you are multiplying across in this manner, make sure that you do this diagonal first before doing the other diagonal. What happens is when it's adding, it doesn't make as big of an issue because the commutative property applies, but when you're subtracting, it does not have the commutative property. The common mistake is that you do 5 times 1 first, put that as the first term, and then you'll do 4 times 1 next, but you can't subtract those and get the correct answer. And I'll show an example about that later. The other type of fraction you can deal with is 1/4 plus 3/8. So what I notice about these two is I can do the smiley face method as we just did before. However, in the end I would need to reduce. What I see is that if I look at the diagonals in this case, what I notice is that 8 is a multiple of 4. So instead of trying to change both numbers like we did in the first example, I'm only going to change the first fraction here. So I'm going to change the first fraction by multiplying 2 over 2 to the top and bottom, because I know that since 8 is a multiple of 4, 2 times 4 will give me 8. So I'll end up getting 2/8 plus 3/8. Add those together and I'll get 5/8. Okay. Now, the last example will be sometimes you need to change both fractions. For example, 1/6 plus 1/9. So in this case, again, I could use the smiley face method because that's a method that always works, but I would need to reduce in the end. And right now I'm just showing you cases where you are less likely to need to reduce. So, we notice that 9 is not a multiple of 6 as we did in our second example. So we go to this third example, which says basically, look at the denominators and see what factors they have in common. Well, I know they're both a multiple of 3. So the first one is 3 times 2. The second one is 3 times 3. So since they both have a 3, I'm going to multiply each fraction by what they don't have. So this fraction, I'm going to multiply the top and bottom by 3 over 3. On the second fraction, I'm going to multiply the top and bottom by 2 over 2. In doing that, I'll end up getting 3/18 plus 2/18. Now the denominators are the same, and all I have to do is add the numerators. So I get 5/18. Okay. So these three examples are examples of how I add, and of course I could subtract fractions as well using these same methods. So there are 3 different examples. Let's try it with our expressions now. Let's take this 2 over x minus 3 minus 1 over x minus 2. In this problem, I notice there's not a lot in common between the two denominators. So I'm going to use the smiley face method. So I multiply the two denominators to each numerator, and then I multiply the denominators together. So I end up getting 2 times x minus 1 minus 1 times x minus 3 all over x minus 3, x minus 1. So in this case, we see that I can distribute the terms in the numerator. So I'll get 2 times, 2x minus 2, and then I'm going to distribute negative 1 into the second parenthesis. So I'll get negative x, let's keep it in black here, plus 3, all over, here I could FOIL if I want to, but just for this problem, we're going to keep it without FOILing it out. Now, adding the like terms in the numerator, I'll get x. Adding the like terms again gives me plus 1. All over x minus 3, x minus 1. Now, in finishing this problem, I could FOIL the denominator out here if that's what I chose to do. In this case, I'm just going to leave it as is and say that this is my final answer. Okay? So this one, in example 1, similar to example 1 that we did before, all we did was use the smiley face method. In this example, we have 3 over x plus 2 plus 4x plus 5 over 3x plus 6. What we're going to do is try to factor as much as we can the denominators we're given. The first fraction does not have a denominator that needs to be factored. The second one, however, does have a denominator that can be factored. So, in factoring it, we'll end up getting 3 over x plus 2 plus 4x plus 5 over 3 times x plus 2. Now we see that both denominators have an x plus 3 in common. So again, I just want to change one of the fractions in this case. So I'm going to change the first fraction by just multiplying a 2 over 2. In doing that, I made error, 3 over 3. So we're going to multiply this out, and we'll get 9 over 3 times x plus 2 plus 4x plus 5 over 3 times x plus 2. Now the denominators are the same. All I have to do is add the numerator. So in adding the numerators, I'm going to add like terms. So I get 4x plus 14 over 3 times x plus 2. Again, I'm pretty much done with what I need to do, so here's my answer. Let's try one more problem. Okay, so the last example here, we're going to first look at the denominators and factor it out completely. So, in factoring them completely, I'll get 3, and the denominator here is x plus 1, x plus 1, plus, factoring the denominator here, I see it's the difference of squares, so that's x plus 1, x minus 1. Now, in this case, I see that they both share at least one factor in common, and that's x plus 1. So the first factor, I need to multiply an x minus 1. The second fraction, I need to multiply x plus 1. So in doing that, I'm going to multiply x minus 1 to the top and bottom of the first fraction. Plus the second fraction, I'm going to multiply x plus 1 to the top and bottom. Alright, now distributing in the parentheses, I'm going to end up getting 3x minus 3 for the first numerator, plus, I can distribute a 1 in, but it's going to stay the same, so I'm going to say x plus 1, and my denominator is x plus 1, x plus 1, x minus 1. Now in the numerator, I'm going to add all the like terms, and I'll end up getting 4x minus 2 all over x plus 1, x plus 1, x minus 1. And that is my answer. Okay? Thank you very much.